We're all using AI for, well, pretty much everything these days. But if you ever stop to think about the hidden cost of a single prompt, it sounds like a simple question, but the answer is surprisingly complex, and it tells us a ton about the future of sustainable tech. Let's dive in.
So let's start with the big question. How much energy does one little AI prompt really use? You'd think there'd be a straightforward answer, right? A single number we could all point to, but as it turns out, the public data on this has been, well, let's just say it's a bit of a mess.
Just look at this table. It shows the problem perfectly. These public estimates are all over the map. For some context, 1 watt-hour is about what it takes to power an LED light bulb for an hour. So you've got one study saying it's around 3 watt-hours, another saying it's 10 times less at 0.3, and others giving this huge range. This kind of confusion makes it practically impossible to have a real productive conversation about AI's environmental impact.
So what's going on here? Why the huge differences? Well, the issue isn't really with the AI models themselves. It's about how we're measuring them. It's a classic case of everyone using a different yardstick, and when you do that, you get wildly different results.
Okay, so it pretty much boils down to two different ways of looking at the problem. On the left, you've got the common approach you see in a lot of public studies. It just focuses on the AI chip, the GPU or TPU, while it's running. Think of it like measuring a car's fuel efficiency by only looking at the engine while it's on a test bench. But on the right, you have the comprehensive full-stack approach. This measures the entire system in its real-world operational environment, which gives us a much more accurate picture.
So what does this full-stack view actually include? It breaks down into 4 key parts. First, you've got the energy for the core AI chips. Second, you add the power for the computers hosting those chips, the CPU and memory. Third, and this is a big one that a lot of studies miss, is the energy consumed by idle machines. You know, the servers that are kept on standby to handle sudden spikes in traffic. And finally, number 4, you have all the data center overhead, the cooling, the power systems, everything it takes just to keep the lights on and the whole operation running smoothly.
And here's what that looks like in practice. When Google actually measured their Gemini model this way, the AI chip itself, the only part most studies even look at, was just 58% of the total energy bill. The other 42% came from the rest of the system. That is a huge piece of the puzzle that was being completely ignored before. All right, so now that we're all on the same page about how to measure this properly, it's time for the big reveal. Using this comprehensive, full-stack measurement, what is the actual environmental footprint of a single Gemini prompt?
The number is 0.24 watt-hours. That's the median energy use for one prompt measured across the entire system. Okay, but what does that number actually mean in the real world?
Let's put that into perspective. It's less energy than you use watching your television for just 9 seconds. All of a sudden, that abstract number becomes something you can actually wrap your head around. It's a tiny slice of our everyday energy consumption.
And you know, it's not just about energy. They applied the same comprehensive measurement to water usage. And the result? Just 0.26 milliliters per prompt.
To put that into perspective, that is literally 5 drops of water. This is orders of magnitude smaller than some of the wild public estimates that were suggesting it was closer to a small bottle of water. It just goes to show how critical it is to have accurate, first-party data. But hold on, because here's where the story gets really dramatic. That 0.24 watt-hour figure isn't a static number. The most incredible part of all this research is the sheer speed of improvement. We are talking about an absolutely astonishing leap in efficiency. The timeline we're talking about here is just 1 year. But in the world of AI, a single year can feel like an eternity, and the progress that was made in that short time is, well, it's staggering.
Get ready for this. In that 1 year, Google managed a 44-fold reduction in the carbon footprint for a single prompt. No, that is not a typo. 44 times more efficient. This isn't just some small incremental improvement. This is a revolutionary leap forward.
And here's how that breaks down. It was a 33x reduction in the raw energy needed, and when you combine that with using a cleaner energy mix in their data centers, you get that massive 44x drop in the total carbon footprint.
So how in the world is a gain like that even possible? Well, it wasn't one single magic bullet. It was a true full-stack approach, optimizing every single layer of the operation. We're talking smarter models that only activate the parts they need, running on custom-designed, hyper-efficient hardware housed in some of the most energy-efficient data centers on the planet, all while being powered by cleaner energy. Every single piece of the puzzle was improved.
So,
what's the big takeaway from all this? Why does getting these numbers right matter so much, not just for one company, but for the entire industry?
This chart just drives the point home perfectly. If you use that narrow, old approach, you get a number like 0.10 watt-hours. But the comprehensive, real-world measurement is 0.24. It's 2.4 times higher. This proves that what you choose not to measure can totally distort the truth of AI's actual footprint.
And that brings us to a really key line from the research paper itself. For environmental metrics to be actionable and comparable, it is critical to consider a standardized measurement boundary. In other words, if we don't have a shared, honest standard for how we measure this stuff, we can't compare apples to apples. And if we can't do that, we can't really drive the kind of efficiency gains the whole industry needs.
Because ultimately, the goal of publishing all this data and this methodology isn't just about patting one company on the back. It's about setting a benchmark. It's about encouraging a race to the top for efficiency across the entire field of AI, making sure that as this technology scales, its environmental impact doesn't scale with it. Which really just leaves us with one final critical question. The age of AI is growing exponentially. As it becomes woven into the very fabric of our world, is a shared, transparent, and comprehensive standard the absolute key to making sure this incredibly powerful technology grows up responsibly? That's a question for the entire industry to answer.